Hello everyone. In today's video, I am going to introduce a new feature called particle set in image matrix. So traditionally when we do particle analysis, we can only do one particle analysis at a time for each image. For example, in this image, I can perform particle analysis on protein-bound DNAs. And I have one particle here, but I cannot do another particle analysis that occupies the same area as this DNA. For example, if I want to add additional particle analysis on these localized protein DNA complexes, I cannot do that because if two particles have their masks overlapped, they count as one particle instead of two, right? So they cannot coexist with this particle. So that's why we have to do a separate particle analysis for this localized protein DNA complex. And in the old way, we have to delete the first particle analysis in order to do a separate particle analysis on these localized complexes. Now, by introducing a particle set, we can perform multiple particle analysis by simply separating them into different sets. For example, in the first set, it's like a mini workspace, right? In that set, we can perform particle analysis on protein-bound DNAs only, and then we can switch to another set, which gives us like a blank state. Then you can do your own masking and analyze a new set of particles. And it's also useful when you want to analyze particles in different channels. For example, you can analyze one set of particles in one channel, let's say the trace channel, right? Or the height trace. Then you probably want to analyze another set of particles in, let's say, phase channel or the retrace channel, the height retrace channel, right? So you can perform multiple sets in that kind of scenario. So yes, let's see how it works in image matrix. Right now I have my image processor open, and as you can see that I have my particles already analyzed in the height trace channel. So let's just go ahead to analyze another particle set. To do that, let's click the Analyze tab, and you can find the particle sets under this drop-down menu. Now we have the default set, which is the first item. So we're in the default set right now. That's we analyzed particles in the height trace channel. Okay, so let's go ahead to make a new set and analyze particles in the height retrace channel. Just for example, so let's click New, and let's say height retrace. Click OK. Now we add a new particle set that's called height retrace, and you can see that in this set, right, we don't have any particles analyzed. It's blank. So now we can simply analyze the height trace channel. Let's click the height trace, and you can do all the things you want to do, like the image correction. I would need to analyze the retrace channel. So let's do that. Let's go to use some automated image processing. Let's go back to the miscellaneous tab. Let's click My Apps. Let's click image processing. Now, if you cannot find this macro, you can load it by using Add App. It's under the scripts folder in the image matrix programs folder. So let's just click that. That automates this processing for us. Select the image, select the height retrace. That's what we want to analyze. Let's do that, and then it automate the image correction for us, and then perform particle analysis at the end. Now we have finished analyzing all the protein-bound DNAs, I believe. Yes, I also believe it's just merely DNA, not protein-bound DNA. So it includes free DNA, as you can see here. So yeah, let's do things a little bit differently. So instead of analyzing DNA, let's just analyzing the localized protein DNA complex, as I shown you earlier, like in this. Okay, so on the image matrix, I can use a custom mask script to do that. Let's just simply delete this analysis for now. And you can see we already have another particle set here in the height retrace channel. That's different from the one that we saw earlier in the default set. Right? Let's go to click the results and delete the current analysis. And let's go to the mask tab, click morphology, click mask protein DNA complex. Now, if you cannot find this script, you can load it by clicking customize and click load, and you can find the script under the scripts folder. It's called the mask protein DNA complex. Just click that and make sure that you use this script on a correct image. So right now you see that we have the protein DNA complexes masked. That's the localized protein DNA complexes. All right, so this is our new particles. Let's click analyze. Now I have 6 particles in this set. Okay, now to see the results in the 2 sets, let's go back to the default set. Now we are back at the default set, right, with 28 particles. Next, I'm going to show you how to manually add particles into a particle set inside Region Inspector. Now, what is the usage for that? And as you see that we just performed particle analysis, that's like a bulk particle analysis. And well, the benefit of doing bulk particle analysis is that it's high throughput and it's like an automated procedure. And but the downside is that we do not have enough information on things such as position property. For example, if I go back to the height retrace channel, now as you see, I have these 4 particles, and they are on DNAs, right? Let me zoom in this. Yes, so I know the various metrics of the particles such as volume, area, and height, but I do not know its position on the DNA. I don't know where it is on the DNA. That kind of information cannot be obtained through the traditional particle analysis. That's why we need the region inspector. Now, while the region inspector, we can analyze the positions of these complexes on the DNA. And if we can manually add those complexes with their positions as a context information, right, into our particle set, now we can have their position information. Let me show you. Let me show you how to do that. Let's click on the region inspector. Now, before we do that, we need to use a set, right, that has the DNA on it, because we need to trace the DNA, right? These particles, right, they do not give us the DNA, so we cannot know their position. So we need to use a set that has DNAs in them, right? And so these ones are not so great because the DNAs are kind of disconnected. Let's just reanalyze this set for now. Yes, let me see. To do that, let me just delete this. And set a bit of my parameters. Make sure the DNA has proteins bound. I want to set its height information as well. Make sure it's above 1 nanometer. Now this area already specified and as larger than the free protein, so just make sure only the DNAs are masked. Let's click OK, and I want to apply the mask. Now we have that. Let me just click Analyze. Now we have all the DNAs masked and analyzed as particles. Now we can click Region Inspector. Now we are inside the Region Inspector. Let's first make a quick analysis on this DNA molecule. Let's click this DNA molecule and let's trace that to find the location of the proteins on the DNA. And let's click the custom recording. I use the profile called Find Peaks. Now if you cannot find that, you can click Load Profile and find this profile under the scripts folder. Let's click that. Now it finds the location of these two peaks. That's the location of these two proteins. Now the row 1 represents this protein, and row 2 represents the second protein. So next thing I'm going to do is I'm going to analyze the size of the protein and its other metrics. But to do that, let's first draw a region of interest around this protein complex. Let's add these to the respective rows. And its other particle metrics such as area, volume, and stuff like that. So yes, we have all the information, including their position context. Now the next thing I'm going to do, I'm going to add them to a new particle set. Now to do that, let's turn off the region of interest. Let's try to mask only this protein complex by clicking on Mask outside of this area. You can turn off the transparency to see them better. So I'm going to add these complex into a new particle set. Now to do that, let's select its matrix in its row. First, this first row represents its matrix, okay? Let's right-click this complex. Select Add to Particle Set. Let's just pick any set for now. We can make a new set inside as well. Or you can just simply say click Add to New Set. Let's say PD complex. So as you see, we have these dialog pop up to us. We have this particle. And the reason I include a little bit of DNA arms flanking this protein complex is because I want to know its DNA binding context. So when I view the particles individually, like for example, in particle classifier, I can see how it bends the DNA, right? Because I have the DNA arms included in its image as well. So on the right side of this dialog box, you can see its particle metrics. Now that's exactly the same as the first row that I selected here. So I have all the information about this complex. So not only its area, volume, right? But also its position context. Okay, it has its position on the DNA and the total length of DNA. And why that's important to include the position information? And that's because in typically in protein DNA analysis, for example, in my study, so I studied DNA repair. So the DNA repair proteins would specifically bound to a DNA structure such as a damaged DNA site. So the position matters, right? And if the protein binds to a damaged DNA site, it can exhibit in a specific conformation versus when it binds to a non-damaged site. So we need to know the position information so to distinguish potential differences in their conformations. So that's an important context that we need to know, which cannot be told from particle analysis, right, in the traditional way. But in this way, since we manually add this complex into our particle set, right, we can include these position contexts in addition to its other regular metrics. So let's just click Add. So once we finish adding this particle to the new particle set that we chose, we can add the secondary one. To do that, let's remask this DNA again. Let's do that. Crop this particle, select Unmask outside of this area. Then simply click this. Let's select its matrix first. You need to remember to select its respect row, otherwise you're adding the wrong matrix. Select that, add PD complex. Now this time we have the same thing, right? Just click Add. All right, we're done with these two protein DNA complexes. Then we can go back to our images in the image processor. Like you can see that this is our default set, which masks the whole DNA molecule. Now if we turn that to the PD complex set that we have, and it's going to show the two particles, the two protein DNA complexes there. Now if you click to show its results, of this manual particle analysis, you can see the two particles, their metrics, and okay, this is a regular ones, but also it includes the position information as well, like this, and of course the total length of the DNA as well. So yeah, it includes the position context of these molecules. So then once we have these particles with their position context, then we can go on to do particle analysis or particle classification, and with the added benefit of knowing where they are on the DNA. So let me show you another thing that you can do with the particle set concept. Let's go back to the default set. Let's turn to the next molecule. Yeah, we don't need to save this right now. If you want to save the analysis, of course, you have to click Save. But for today's video, we don't need to save the records. Just click No. Now we have another particle, DNA here. Let's just imagine this is a one that I don't know how to analyze, okay? This could be like two DNA molecules, or could be one singular DNA molecule, because it's kind of iffy here. They could be separated, or they could be connected. So let's just say I don't want to analyze this today. It's complicated. I'm going to defer that to some other days with my colleagues to determine how to best resolve this DNA molecule. Now, the protein set concept allows you to defer that analysis. For example, you can simply right-click this molecule. I can say, okay, I'm going to add this to a new set. It's called to do. So it's going to let me add this molecule into a set called to do. So the benefit of doing this is by adding this to a set, I don't have to analyze anything about this. I don't have any metrics about this, but I would know its location, right? And such that I can go back to to analyze it in the future. So, for example, I have already included this particle in my to-do set. Let's go to click that. Now, if you zoom in, you can see in this to-do set, there's only one molecule. That's the one we just added into this set, right? So let's say I can save my workspace into a file, right? And I can go to sleep, and then after a week or two, when I converge with my colleagues, right, I can go back to this analysis. I can reopen the workspace file and then go back to the to-do set, right? Then I can go back to the region inspector and analyze those unanalyzed particles. So you can put them in a deferred list, right, to-do list. So that's another usage for using this particle set. So you can analyze individual protein DNA complexes that's separated from your main analysis, right, that only analyze the DNA molecules. You can also analyze, right, different particle analysis. We can also perform different kinds of particle analysis. So one on the hide trace channel, right, and one on the hide retrace channel. So yes, now we have the hide retrace set as well, right? It's a different set. You can also perform on, say, a phase channel if you have that. So, and you can also put them in the to-do list. Maybe you have other interesting usage of of this set feature. And I think it's a very powerful feature. It enables you to perform multiple particle analysis on the same image at the same time, right? You don't have to delete or make a separate workspace files for that purpose. You can include all at once. You can even do multiple particle correlation results, right? Just put them into different sets. And that's all for today's video. Thanks for watching, and I will see you next time.